ఇంటర్మీడియట్ విద్యారంగంలో అగ్రగామి మన NSR ఇంపల్స్ ఎడ్యుకేషన్ ఇన్స్టిట్యూషన్. ఐఐటి జేఈఈ అయినా నీట్ అయినా తిరుగులేని విద్యా సంస్థ NSR ఇంపల్స్.
Let us continue with the concept of plant growth and development. What we studied for the last class? Growth curve if you take, or growth rate if you take, we have two types of growth rate we studied. What are they? Arithmetic growth rate, and geometric growth rate. Right, do you remember? So we studied what? Growth rate is of two types, arithmetic growth rate and geometric growth rate. So what are the formulas we studied for this? LT is equal to L naught plus RT. So this is for calculation of arithmetic growth rate. Coming to geometric growth rate, W2 is equal to W naught ERT. This is for geometric growth rate. Similarly, now if you talk in terms of growth rate here, as we going on discussing arithmetic and geometric growth rate in different cells, in different metabolic pathways, especially to measure the growth rate, we take into consideration of more two types of growth rate. So what are the more two types of growth rate? I'll write again. Growth rate is also further divided into two categories. One is called as absolute growth rate, and other one is called as relative growth rate. Okay, what are the two things we have to study? Absolute growth rate, AGR we call absolute growth rate, and another one is called as RGR, relative growth rate. Absolute growth rate and relative growth rate, what are this? So for the last class we studied about arithmetic growth rate and geometric growth rate. Growth rate also can be measured by taking into consideration of two more parameters called absolute growth rate and relative growth rate. What is absolute growth rate? AGR. AGR, if you take absolute growth rate, it's nothing but measurement and comparison of growth per unit time. Measurement and comparison of growth per unit time. Senior BPC people, from here, from this video onwards, be serious guys. Make sure that you do some work from today, from this class onwards. Be serious. Like other people, they are every day they are practicing and they are reading, they are understanding the concept, everything they are learning, and they are writing without saying, and those worksheets they are sending to the personal WhatsApp. So I expect some unknown people are also doing some work. You all are my known people. I expect each and every girl, each and every boy, make sure that you start writing your running notes in your botany notebook. Listen carefully with full concentration, and once you give one revision after you complete the class, revise in your mind, study well and revise in your mind, and try to learn the concept. And once you write in your running notes, right, just stop the video in between, write down your running notes, and after that again you try to learn the concept. Once again you write without saying on a separate white paper. So whatever you write without saying, after you learn the concept thoroughly, everyday class is very little. What I am giving you, little input, little part of information, right, not so much. So whatever you listen and understand that day, on the same day you complete your preparation. Write once if possible, write once without saying on a white paper, and try to send me that worksheet to my number, so that I will come to know who are the people who are really making a serious effort in understanding, in learning, and making it to present on a white paper without saying. And that work, once if I see, that is highly appreciated. So guys, make sure that from today, make sure that you take your notebook, start writing the concept, theoretical concept, listen with full concentration, and it becomes very easy if you practice once or twice. Okay, so let us continue now. For the last class, growth rate, we studied arithmetic growth rate and geometric growth rate. Now what we are studying, growth rate can also determine with two more parameters. What are they? We say absolute growth rate and relative growth rate. What is absolute growth rate? Measurement and comparison of growth per unit time. Measurement and comparison of growth per unit time. So if you take this measurement and comparison of growth per unit time, if you take this can be studied by taking an example of, I will erase the upper part, I hope it is clear to you. So here we say that absolute AGR, absolute growth rate is equal to final weight, or we can take final length or final surface area minus initial surface area or initial length by initial length. So the same thing what I write here, for example if I talk, I am writing same thing here, AGR. So here I am just writing growth rate. Growth rate, we have AGR and what we call RGR. So what is this AGR? Absolute growth rate. What is this RGR? Relative growth rate. So absolute growth rate can be written it as AGR is equal to L final weight, no, LT minus L0 by L0. So this is a formula for absolute growth rate. I repeat again, it is a measurement and comparison of growth rate per unit time. What is that measurement? We are trying to measure the growth. What is that comparison? Comparison of final length and initial length, final weight or initial weight. We are just comparing earlier how much growth rate initially, and after time t how much growth rate has taken place, and we are taking out actual growth rate per unit time. So this is nothing but what we call absolute growth rate. Coming to relative growth rate. What is relative growth rate? Here we can say growth of the given system, growth of the given system per unit time. Growth of the given system per unit time. So here whatever we take here for relative growth rate, we can take relative growth rate is equal to LT minus L0 by time t. Okay, LT minus L0 by time t. So here in both the cases if you observe, for example I am drawing example here, this is a leaf. So this got increased, initially it is 10 centimeters or you take only 5 centimeters, okay, and in 1 week of time it has become now it is 10 centimeter. Let us take this is A and let us take this is A0 or A1, okay. Initial length surface area of the leaf is 5 centimeters, okay. After some time the later total surface area has become increased to 10 centimeters. So what is absolute growth rate here? Absolute growth rate is equal to 10 minus 5 by 5, that is 5 by 5 is equal to 1. So 1 is nothing but what? Absolute growth rate. I hope you got it. What is absolute growth rate? Final length after time t, initial length by initial length, that means a final surface area minus initial surface area by initial surface area. So finally it is almost 10, and it got 5 initially, and 5 by 5 is equal to 1. This is nothing but what we call absolute growth rate. Coming to RGR, what you call relative growth rate. What we say in case of relative growth rate? Growth of the given system. So, in this case, for example, we take a leaf. This is altogether already 50 centimeter square, or whatever called centimeter. Now, there is a slow rising leaf surface area, and here this is 55 centimeter square. Maybe in 1 week of time, so here you can write final length minus initial length by time t. That means here how much got increased from here to here? 5 centimeter. That is 55 minus 50 per unit time. So, how much it will become? 5 centimeter square per unit time. The time may be a 1 week of time, 7 days, 1 week of time. For 1 week, actual growth of the given system per unit. Growth of the given system is at that time how much growth has taken place. That itself is called as relative growth rate. So, here how much got increased means 5 centimeter. This is the growth of the given system. Growth of the given system per unit time, it is called relative growth rate, and comparison and measurement of the growth is called absolute growth rate. How much it got increased? What is the growth at this time? How much it got increased? 5 centimeter square. At this time, growth of the given system, in this particular system, growth has taken up to 5 centimeter square. That is called relative growth rate. What is absolute growth rate then? Growth measurement and comparison. Measurement and comparison. What was the initial weight? What is the final weight? Comparison of that compared with the initial time, and that will come under absolute growth rate. Right. So, these are the cases. Let us imagine this is B, and let us take this as B1. I hope now you got very clearly. Okay. I repeat again. Listen carefully. Growth rate, it is of two types: absolute growth rate and relative growth rate. Take one notebook, your botany running notes you take down. Copy down with neat handwriting the two types of growth rate. They are very easy if you practice and understand and revise it once or twice. So, how do you define AGR? What is AGR? It is nothing but measurement and comparison of growth per unit time. You are measuring the growth by comparing final time, final weight and initial weight, final length or initial length, final surface area and initial surface area. You are comparing at that particular growth time per unit time itself is called absolute growth rate. Absolute growth rate is equal to final length minus initial length by initial length. The same thing can be written it as AGR. Absolute growth rate is equal to LT, length after time t, minus L naught, length in the initial time, by length in the initial time. For example, a leaf has increased. Initially it is 5 centimeter. Within 1 week time it has become 10. Here also the growth has taken place is 5 centimeter only. But what is absolute growth rate? It is a comparison. So, we take absolute growth rate is equal to 10 minus 5 by initial growth, that is 5. 5 by 5 is equal to 1. So, absolute growth rate is 1. Similarly, coming to second, that is relative growth rate. What is that? At this particular time, what is the growth of the given system? What is that? Growth of the given system per unit time. How much growth got increased? How much growth got taken place? That is what is called as relative growth rate. So, for relative growth rate, we can say L naught minus LT, or we can say surface area of final after time t minus initial surface area by per unit time. That is, if they take the leaf 50 centimeters, got increased up to 5 centimeter high, finally is 55. So, 55 minus 50 is actual growth rate taken place is only the growth of 5 centimeter, and per unit time itself is called relative growth rate. Okay. So, this is what is called absolute growth rate and relative growth rate. Practice on the paper, just try to remember in your mind. Now all of you, what you can do is take one horizontal page, divide into 3 columns. Now we are going to discuss a comparison of 3 processes. It becomes easy if you can divide into 3 parts. Take the horizontal page and we are going to discuss the 3 parameters, allot the space equally to 3 parameters, so that you can continue 2 horizontal pages. The information you write down so clearly with giving little space, note down very with neat handwriting, so that you can take 2 horizontal pages, continuation of 2 horizontal pages, right. Now let us discuss about growth processes. Growth processes. What are the processes which are involved in the phenomena called growth? Let us take growth processes. Now altogether, generally the growth processes can be divided into 3 categories. Let us take all 3 categories. First one is called differentiation. And second one is called as de-differentiation. And third one is called as re-differentiation. What are the 3 processes we have? Differentiation, second one is differentiation, and third one is re-differentiation. So better you can take a hyphen here, right. Okay. So now let us study about 3 processes: differentiation, de-differentiation and re-differentiation. Now let us talk about differentiation. So what do we understand in case of differentiation? Now I will give you the definition for differentiation. So make sure that you try to follow and listen carefully. So it is nothing but the process of, or we can write the biochemical process or a morphological process. A biochemical process or a morphological process which makes meristematic cell, to undergo cell division followed by elongation and maturation. It is called differentiation. It is called as what? Differentiation. What is the meaning of the definition here? What is the meaning of definition here? Now if you take a biochemical or a morphological process, what is the meaning of this? Either you can say the biochemical changes may take place, the chemical composition or the chemical processes may undergo some changes, or morphological changes. What is the morphological changes? Structural changes. Morphological means structural changes, and which makes the meristematic cell to undergo cell division. So if you talk about meristematic cell, this story we know very well. You know that at the tip we find, you know what it contains is called meristematic cell, visible here. Yeah. So here what we find here is nothing but what we call a meristematic cell. So if you take this meristematic cell, what is the function of this meristematic cell? We know it very well. We discussed earlier, it will undergo the process called cell division. Divide 2 cells will become 4, and it increases in growth. What happens here? It increases in growth. Okay. So here cell division occurs, then followed by cell elongation, cell division and then followed by cell elongation. So this is how the elongation occurs. Cell elongation and then followed by cell differentiation. Right. So what we discussed earlier? These 3 phenomena you know very well. Together it's called growth. What are they? Cell division, cells will divide. Newly formed cells elongate in size, they get elongated here and completely they matures and become permanent cells. It's called what? Cell differentiation. So what are the three processes? Cell division, cell elongation and cell differentiation. So in this case what happens? When cells are differentiated structurally and functionally, when cells are differentiated structurally and functionally, they are called as what? Guys, you know very well. They are called as what? What do we call them? You know that, right? What are they? They are called mature cells, or we call them as what? Permanent cells. Alright. So here what's happening here? So here a biochemical morphological changes which makes the meristematic cell to undergo cell division and cell elongation and maturation itself is called as the phenomena called differentiation. So finally we can see formation of mature cells or permanent cells. What are mature cells and permanent cell? Every cell is structurally and functionally it will get differentiated. Structurally it may become parenchyma cell, or it may become collenchyma cell, or it may become sclerenchyma cell, and functionally also. Functionally means here what happens? Every cell is assigned to do a specific function, and structurally, functionally when cells are completely developed, they are called mature cells or permanent cells. The formation of mature cells and permanent cells from where? From meristematic cell, it's called differentiation. So we know number of times we discussed, people can understand very easily what is called differentiation. Now let us study some of the examples for differentiation. Guys, you just continue writing down in the horizontal page, you go down continuation of this to understand and to check with the examples. For myself, I am just writing, instead of you people continue writing down, but I am writing here. What I am discussing? Still I am discussing the process called as what? The first one only, don't get confusion, the first one only I am writing. What is that? Differentiation. What is that first one? I am continue. You people continue writing down in horizontal page. Go to the next horizontal page. Continue and try to see that all differentiation points in one column, right? So let us talk about examples. So what are the examples here we can take? Let us take the first example, you know, root elongation. Root elongation, or we say root growth. Okay, root elongation, or we say root growth. What happens in case of root elongation or root growth here? In generally, you know it very well. At the tip of the root, what do you find? Meristematic zone. Meristematic zone contains what? A meristematic cell. Right. So here, not only the root elongation, general example if you take, you can also talk about shoot apical meristem. General examples, shoot apical meristem. Why do we write shoot apical meristem? Tip of the shoot contain meristematic cells, they undergo cell division, they elongate in size and finally they get differentiated. That is what in few classes, before classes also, number of times we studied to define the phenomena called as what? Growth phenomena, shoot or tip of the shoot, shoot apical meristem. Similarly, we can take root apical meristem. What we can take? Root apical meristem. So here shoot apical meristem, root apical meristem are very good examples directly for the growth phenomenon that we can take it grant as the first phenomena called differentiation. So for us example, we are taking root apical meristem, tip of the root here. So this is nothing but root tip here. So what you find here? Meristematic cell. Now this meristematic cell, what you find at the tip of the root, now it will undergo the phenomena called cell division. As a result, new cells are produced and these new cells, they undergo the phenomena called cell elongation and matures to form, and they get matures to form root hair. Better I will write down like this. What I will do is I will try to write this side. So, they matures to form what? They matures to form root hair. What is happening here? Now this cell, what is undergoing cell division here? New cells are produced, they will undergo cell division like this. What extends and produced here? It is called root hair. Got it? It may remain as it is as in the form of meristematic cell, or it will further undergo cell division, undergo elongation, undergo differentiation. As a result of differentiation, the newly formed cells from meristematic cell, they matures and they assign with specific function structurally and functionally. Now they are called root hairs. Okay, at the tip of the root you can contain root hair, or you can also call that sometimes what you find here, what you find, sometimes you find in some cases root pocket. First year morphology, you remember? In some cases, in some plants, root is protected by root pocket. So, this we can take as a first example. What is happening in the very first example? Tip of the meristematic cell is undergoing division, elongation and differentiation, matures to form either root hairs in some plants, or they mature to form what is called root pocket. This process is called as differentiation. Similarly, let us study some more examples. Here examples are very important. This is the first example. Let us continue with the example number 2. In the early stages of formation of the growth of the young plants, that means in anatomy what we studied, primary growth, secondary growth. Did you remember? So, let us talk about primary growth. What happens in case of primary growth? So, in case of primary growth, you know the young plantlet contain procambium. What it contain? Procambium. Right. In early stages of development in the anatomy, the first formed cells in leading vascular bundle, they are called cambial cells. First formed, so they are called procambium. So here it is what you find, procambium. So the procambium cells, they will undergo cell division on either side. Here also cell division, and then followed by cell elongation, and then followed by maturation or formation of permanent cells. So here also cell elongation, and as a result of this maturation and lead to formation of that cells, a mature cells, a permanent cells. What do we call them? So here you find what are called as phloem. They are called primary phloem. And similarly in downward direction, they are formed what are called young cells, which are produced here, called primary xylem. It leads to formation of what? Vascular bundle. It leads to formation of what? A vascular bundle. Who is the source here? Procambium. Okay, in the primary growth, in the anatomy part, in the primary growth, in the early stages of development of young plantlet into an adult plantlet, what happens? Centermost cells which are produced here, they are called, I repeat again, they are called procambium. Procambium cells will undergo cell division, followed by cell elongation, followed by maturation. Structurally, functionally cells are differentiated. How do they differentiate it? The cells which are formed on upper side, they differentiated into phloem and they produced at the time of primary growth. That is why they are called primary phloem. Similarly, the cells which are produced towards center, towards pith or medulla, and they also mature, and structurally functionally they undergo differentiation. Structurally functionally are different from these cells, and what we call them as what? A primary xylem. So what is that we find? Procambium lead to formation of primary phloem, primary xylem. Ultimately it constitutes the formation of vascular bundle. It's a very good example for differentiation. It's a good example for differentiation. Simply remember, procambium gives rise to primary phloem and primary xylem. This happens by the phenomena called differentiation. Similarly, let us talk about another example. Example number 3, we are discussing for differentiation. What do we study here? Now here the parenchymatous cells. So here these parenchymatous cells, the parenchymatous cells, what we find here, these parenchymatous cells loses protoplast and convert into, maybe you can take sclerenchymatous fibers, or they may develop into xylem tracheids, or they may form thick lignified secondary cell wall. What is this? Okay, so this may be meristematic cell. Better you take down, these are meristematic cells. Better you take down, these are dividing, no? Meristematic cells. Why we are taking meristematic cells? Because they are in the process called cell division. They are dividing. Okay, these meristematic cells which are produced as a result of cell division, they are new cells, they elongate. And when do they become mature cells or permanent cells? They undergo maturation, differentiation. Cells are structurally and functionally they are differentiated. For example, some of the meristematic cells which are produced here, they loses their protoplast, loses water, loses their protoplast. What is protoplast? Living content of the cell. What is protoplast? Living content of the cell. When they lose protoplast, they may convert into a sclerenchymatous fibers. Sclerenchymatous fibers, you know xylem fibers. What is sclerenchyma? Dead cells. Why? They loses the protoplast. They convert it into dead cells. What are the dead cells called? Sclerenchymatous. These losing protoplast, they may convert into fibers, xylem fibers. So what do we call them? Sclerenchymatous fibers. Okay, or sometimes they loses protoplast, they may convert into what? Xylem tracheids. Some cells are structurally, functionally converted into fibers. Some other meristematic cells structurally, functionally they convert into tracheids. Tracheids also they are dead cells, right? They are made up of sclerenchymatous, they loses protoplast. Or some of the meristematic cells, apart from these two, some more meristematic cells, their cell walls become very thick. They will become very thick. After losing protoplast, they will become very thick and they become lignified. Lignin will be filled, deposited, where? And lead to formation of secondary cell wall. The wall may become thick and it may be filled with lignin, and that leads to formation of what? Secondary cell wall. Some meristematic cells after losing protoplast, they may convert into sclerenchymatous fibers. Some more meristematic cells structurally, functionally they may develop into xylem tracheids, and some more meristematic cells and they become thick and they deposit lignin and they mainly contribute for the formation of secondary cell wall. So, these all are nothing but examples for what? Differentiation. What is that? Differentiation. So, let me give you questions. Generally, the people will get confusion here. So, let us talk about questions. If you look at the questions, whenever in the question, if they give about root elongation or we say that root growth, or if they give apical meristem, root apical meristem, or shoot apical meristem, formation of shoot apical meristem, or root hair formation, or root pocket formation. Remember, all this will occur by differentiation. So they may ask you the question with the fill in the blank. Root growth occurs by the process called. What is the answer? Differentiation. Root apical meristem occurs, formation occurs by, what is that you have to write? Differentiation. And shoot apical meristem, what is that we have to write? Differentiation. Root hair formation, what we have to write? Differentiation. Is it visible for you? Let me check. Okay, what are the questions expected here? So here there may be sometimes in the question you will get root growth occurs by differentiation. Root apical meristem occurs by, again the options would be differentiation. Shoot apical meristem, differentiation. Root hair formation, answer will be differentiation. Then what else you can write? Procambium, activity of procambium, or you can see formation of primary phloem, or you can say formation of primary xylem. Right. Apart from this, formation of sclerenchymatous fibers occurs by, that is a question, or formation of xylem tracheids occurs by differentiation, or in the question the formation of a lignified secondary cell wall occurs by secondary cell wall, occurs by differentiation. These all are nothing but what? Questions. Presently you feel that you understood the concept, you feel that I understood the concept and I practiced all examples and got it. But in the exam mostly people will confuse about if any question is given, they will be mostly confused and they will go with the wrong option, and after that they will come and tell, madam this is de-differentiation, no, not differentiation, no, they will ask. So better you write all examples at one corner. These are the examples for differentiation. If any question comes on these parameters, you have to take the option. This is a question, this all fill in the blanks. For this you have to take the option called as what? Differentiation. What is the option you have to take? Differentiation. These are the questions for differentiation, not for redifferentiation. This is different. Okay, these are the questions for differentiation. Try to write down the questions also at one corner. Okay, right. Now I hope you got it, all of you, very clearly. Okay, what is that? What is the thing which we have to study here? Okay, so what is differentiation here? Differentiation is nothing but the process of cell division, elongation and differentiated into mature cells or permanent cells. So what is the first example? Root elongation or root growth. Along with that even we can take shoot apical meristem. So here it may remain as in the form of meristematic cell, or it may convert into either root hair or root pocket. So in between what is happening? Dividing, new cells, elongation, maturation, and this is called differentiation. What is the second example? Primary growth. Procambium develops into primary phloem and primary xylem. Example, formation of vascular bundle. Example for differentiation. Similarly, meristematic cells lead to formation of sclerenchymatous fibers, tracheids, lignified second wall. All will come under what? Differentiation. let us go with what is called de-differentiation. What is de-differentiation here? The process of regeneration of a permanent cell or a mature cell to become meristematic cell. To become meristematic cell. It's called as de-differentiation. It's called as what? De-differentiation. What's happening now? Initially we studied, okay, there is a formation of permanent cell, mature cell. Mature cell, permanent cell, generally when you call, why it is called permanent or mature cell? It loses the ability to undergo cell division. Means further it will not undergo any cell division. But in some cases, at some parts of the plant, in some metabolic processes, the mature cells, even though they are permanent and mature cells, but once again they regain the ability to undergo cell division. That means what? This permanent cell, mature cell, once again gain the ability to undergo cell division. Okay, so what's happening here? Permanent or mature cell, once again they gain the ability to undergo cell division. So actually they will lose the ability to undergo cell division. That's why they are called mature cell. But in some cases, in some parts of the plant, in some metabolic functions, mature cells once again they gain the ability to undergo cell division. Then that process they becomes meristematic once again to undergo cell division. That process is called de-differentiation, because already one time they got differentiated. Second time again they are differentiating, as is called de-differentiation. So what are the examples for the de-differentiation? I am writing examples here. Formation of interfascicular cambium. Formation of interfascicular cambium. From where? From medullary rays. You know very well medullary rays. In dicot stem, in between two vascular bundles, what you find is medullary rays. I hope you remember. These are the vascular bundles. This is pith here. What you find here, they are called as what? Medullary rays. These medullary rays, they become meristematic. So here actually they are permanent parenchymatous cells. Once again they become meristematic to undergo cell division, lead to formation of what is called interfascicular cambium. Similarly, one more example is formation of cork cambium. Formation of cork cambium. Formation of cork cambium from where? From pericycle. Okay, formation of cork cambium from where? From pericycle. So both are nothing but good examples for de-differentiation. Okay, I repeat again. Formation of interfascicular cambium is medullary rays. They occur from medullary rays. Formation of cork cambium. You know well anatomy part. You know very well what is cork cambium. You know very well what is called interfascicular cambium. And here cork cambium formation occurs from where? Pericycle. These two are very good examples of de-differentiation. Why? Because if you look at, am I raising the definition? I hope you all understood. Actually they are permanent cells or mature cells, but once again they undergo cell division and they will become meristematic cells. That is called de-differentiation. So here in this case, if you look at these examples, these are already the medullary rays and pericycle, already they are, these medullary rays and pericycle already they are fully differentiated parenchymatous cells. Fully differentiated parenchymatous cells. parenchymatous cells. What's the meaning of that? Already they produced as a result of differentiation. Already they produced as a result of differentiation. Once the differentiation is done, they convert it into what? Parenchymatous cells. And they become mature cells or permanent cells. But once again they undergo cell division, they become meristematic, they undergo cell division. Second time they get differentiated into this. So these are medullary rays, pericycle are formed as a result of differentiation. And they become mature cells, permanent cells. After some time, then here these cells, after becoming the permanent cells, once again they become meristematic and develops into some more components like interfascicular cambium. Interfascicular cambium develops from medullary rays. This is what happens here is de-differentiation, once again differentiated. And pericycle is formed as a result of differentiation, once again de-differentiated into cork cambium. These two are very good examples for what is called de-differentiation. So here I hope you got the examples. Now what is the next one we have? Third one, redifferentiation. So we have to continue for the next one. What is the next one? We have redifferentiation. Okay, so I will continue the questions. What are the questions you will get? You know that interfascicular cambium. Interfascicular cambium. And what is the other one? Cork cambium. Whenever the questions are on this, so what is the answer for these questions? The answer for these questions is de-differentiation. Okay, what is the answer you have to choose? De-differentiation. If the question is on interfascicular cambium, formation of interfascicular cambium is by, choose the option de-differentiation, not differentiation. Formation of cork cambium, it's by de-differentiation. So first one, differentiation is completed, de-differentiation is completed. What is the third one we have to continue with? Redifferentiation.